that not possible?
Well, you have to think about what. Remember, for that to happen, you would have to have.
Because usually the trig functions always go to 1 because they're bound 1 by 1. Do you see what I mean? So it's always going to be 1 or 0. So whatever two numbers you have on the outside usually, or even on the inside, depending if you get 1, are going to be your horizontal asymptote.
So you want x to go to infinity?
Yeah, instead of 0. So
in a trig function?
Yeah.
Okay, so what will happen then? Think about your 6 trig functions. As x goes towards infinity, does it head towards infinity? Any of them?
None of them?
They're all periodic. It can't head towards infinity. It's got to come back down and do something again, right? Even tan, which goes towards infinity at pi on 2 or something, shoots back up under, right? From below in a second. So as you go towards infinity, none of your trig functions are going to head towards infinity, and none of them will head towards 0 either, because heading towards 0 it has a horizontal asymptote, which none of them do. So they're never going to yield a case like that. Okay. They won't yield an indeterminate quotient like that. You know what I mean? So they probably won't have any example like that. Some trivial things. This will be close to what you were saying, Roger. I'm sorry. The limit as x goes to pi on 2. And they give us 2 tan x over secant squared x. 2 tan over secant squared. So before we start applying L'Hopital's rule like a rabid math animal, so make sure it's an indeterminate quotient. What's tan of pi on 2? What's it heading towards?
It's that vertical asymptote, doesn't it?
What'd you say?
It's the vertical asymptote.
Vertical asymptote, heads towards infinity. So what's the bottom heading toward? What's secant of pi on 2 heading? Forget the square for a second. What's secant of pi on 2 heading towards?
Shouldn't that be 1 over infinity then?
1 over infinity.
And that would be
1 over
that'd be
1 over 0, which is heading towards infinity, right?
Yeah.
So this is infinity over infinity case.
Why is it?
So what you're trying to find out is, what is the limit as x goes to pi on 2 of secant x? Well, secant x is the same as 1 on cos. So what does cos head towards as x goes to pi on 2? What's cos pi on 2?
0.
0. So this expression, which is really a secant, is heading towards what? Infinity. It's 1 over 0. It's heading towards infinity, right? So if that's the case, then that means the square of something which is ridiculously large is going to be more ridiculously large. So the bottom's heading towards infinity. The top tan pi on 2, you should know that it's undefined there, right? It's really the same reason, because tan is sine on cos. It's the exact same reason. That's why secant is heading towards infinity, right? Because the cos on the bottom of tan. All right, so we can apply L'Hopital's rule since it's an infinity over infinity case. So what's the derivative of tan? Secant squared. So now the top gets the secant squared. 2 secant squared x. Because x goes to pi on 2. So what's the derivative of the bottom? What's the derivative of secant squared? Don't say tan.
Secant
1 over sine x. Or 1 over.
What do you say?
It's negative
Secant x
cosecant.
dividend x.
That's the derivative of secant, right? The derivative of secant is secant's tan.
Oh, it's 2.
So I've got to pull down the 2. I've got to do a power rule first. So 2, keep the inner function the same, which is now to the power 1, and now multiply by inner function secant, which is secant's tan, which gives us another secant on here, which makes secant squared, and you got an extra tan. So that's a chain rule, right? The power of 2 is the outer function, and the secant is the inner function. Bring down the 2, keep the inner function the same as secant, and multiply by derivative of secant, which is secant tan. The 2 secants become a secant squared. It looks like you now cancel the secant squares and the 2's. That's a good deal. So now you have, I'm not going to write it as cotan, it's not that informative for people who don't really know about cotan. So I'll leave it as 1 over tan. Okay, now we can evaluate this. As x goes to pi on 2, what does tan go towards? infinity. We just said that a minute ago to make sure that this was an infinity or infinity case. So, but now it's the bottom.
0.
0. There's our limit. Any questions so far? We're going to move on to different indeterminate forms now. Products, powers, and differences. Okay? A few more forms. No questions so far? Where's riding easy? Okay. Two other basic indeterminate forms. Product. Difference. And powers. Alright. The indeterminate product is going to be 0 times some sort of infinity, doesn't matter which one, right? If you have something that's structured like that, it's a product of two functions. One is heading towards 0, one is heading towards infinity. You do not automatically know what's going on. Okay? You just don't know. You can't say it's 0 necessarily. So an example like that would be, apparently, x cosecant x. So this would be our first example. Limit x cosecant x as x heads towards 0. So it's a product of two functions. They're not very complex, you know, two regular old functions. So what is x heading towards as x heads towards 0?
0.
Right. What is cosecant x heading towards as x heads towards 0?
1. I mean 0. Hey. Yeah.
Which is to say
yeah,
infinity.
undefined. It should be
That's a good
undefined.
guess. Given this is supposed to illustrate.
It should be. It should be undefined because it's 1 over sine as a
It
sine.
is undefined, but how's it undefined? What's heading towards?
0. I mean infinity.
The bottom's heading towards
Yeah.
0, so therefore it's heading towards
Infinity?
Right, that's right.
It depends on from left or right.
As to
Side.
which
Sine.
infinity it is.
Yeah.
Yeah, it's true. So 0 times some non-signed infinity, right? Actually, I'm kind of surprised they
Wait,
don't
why
have
is
a.
it infinity?
We don't have a plus or minus. Because cosecant is 1 on sine. So what's the limit as x goes to 0 of 1 on sine? Well, the bottom's heading towards 0, right? It's undefined, but in what way?
Oh.
Infinitely so.
Okay, I remember
That's
that
how it's
one.
undefined, right?
Yeah.
So the bottom's heading towards 0. Fixed value over 0 is going to be infinitely large. Alright. And Lee is correct because of the approach here, we're approaching from above the initial side or below the initial side. Alright, so since it's indeterminate product, but L'Hopital's rule only applies to indeterminate quotients. So you need to change this